Welcome back to our series of lectures on rational equations and inequalities. For this lecture, we have lesson 4.2, problems involving rational equations. And our objective would be to solve just that, problems involving rational equations. Okay? And we will be following the familiar resa that you have. Okay? So, let's see. For example number 1. Okay. Okay, let's have the first problem. The denominator of a fraction exceeds its numerator by 4. If 7 is added to the numerator and 3 is subtracted from the denominator, the resulting fraction equals 2. Find the original fraction. In any word problem that you will encounter, you have to identify what we term as keywords. Key. Okay, what does a key do? It unlocks a door. So, keyword would come in the form of formulas or statements, relationships. Also, they come as arithmetic operators. Here, added. Here, subtracted. Or they can come in words like exceed or equals. Okay, those are keywords. Now, you have been taught how to solve word problems by identifying the representation, the variable, equation, the solution, and the answer. Okay, for our representation here, we will let n be the numerator of the fraction. We are expressing the denominator using this numerator here. So this is a reference variable, the numerator. Now, if n is the numerator, how will we have the denominator? It says here the denominator exceeds its numerator by 4. So, my denominator now therefore will be n plus 4. This will be the denominator. Okay? Now, from here, we will have the fraction. What is our fraction? Our fraction will now be n over n plus 4. Okay, now, what will now be our equation? How can we form the equation? It says here, if 7 is added, okay, added is a keyword, to the numerator. So we have here n plus 7, and what do we do with the denominator? 3 is subtracted from the denominator. So this is our denominator. So I get here n plus 4 minus 3. Then the resulting fraction equals 2. Okay. So this is my equation. And then the s here will be your solution. I can now solve this equation. N plus 7 over n plus 1 equals 2. That's a rational equation. I can cross multiply. I will get here what? 2 times n plus 1 equals n plus 7. N plus 7. Solving for n here, I will get here n equals 5. Okay? So, my answer here will now be n over n plus 4. Or, that will be 5 over 5 plus 4. Or this is 5 over 9. Our original fraction. So this is one example where we can expect to have a rational equation to solve. Okay? For our next example, this problem involves work. Okay? A pipe can fill a pool in 4 hours. A smaller pipe can fill the same pool in 8 hours. While a drain pipe can empty the pool in 12 hours. If all pipes are left open, how long would it take to fill the pool? So, for example, we have this swimming pool here. There are 2 inlet pipes. Okay? this first inlet pipe can fill the pool in 4 hours. So the time it takes the first pipe to fill it is 4 hours, and a smaller pipe fills it in 8 hours. Now, a drain pipe, if this swimming pool is full, this drain pipe takes 12 hours to empty it. Now, the situation here is all of these pipes are open. If they will be left open, how long will it take to fill the whole pool? Okay, so that's the situation. If you would recall our work problems, work here is equal to rate times the time. When a job is completed, this one will always be equal to 1. So 1 equals rate times the time. Now, what we have here is, for example, one pipe fills the pool in 4 hours. So the rate of the first pipe will be 1 equals rate times 4, or that will be R equals 1 over 4. It's something like that. Okay? Now, what is our representation? We want to find out how long will it take the whole pool to be filled. Okay, let's say that's the time. Time it takes what? The whole pool to be filled. Okay, let's have the information here for this pipe here. If if this pipe here fills the pool in 4 hours, we will have 1 over 4 will be the rate of this first pipe. Okay? Now, if the other pipe fills it in 8 hours, then the rate of this pipe will be 1 over 8, as we have illustrated solving there. So, rate of smaller pipe. That's how fast it is going to fill the pool. And for the drain pipe, we have here 12 hours. So, the rate of the drain pipe is 1 over 12. Or, this is rate of the drain pipe. Now, I hope you know where 1/4 came from. Here, I explained it there. Work equals rate times time. So, if the pool is filled up, that's 1. In 4 hours, that's a 4. So, this gives me R equals 1/4. That's why we have 1/4 here. What about this one here? The rate here is rate times time. And we get here 1 equals rate times 8. Or, the rate for this pipe will be 1 over 8. Similarly, for this one here, work equals rate times time. 1 equals R times 12, or R equals 1 over 12. Now, that's our representation. What will be our equation? Okay? The equation will be, okay, I will have here letter equation. So, if these two pipes will work together, this will be the combined rate. Okay, combined rate for these two pipes. The intake pipe and the output pipe or outlet pipe will be 1 over 12, and this will be minus. This is the work done by the 3 pipes, okay, in 1 hour. So that will be a fraction of the total time it takes them to do the work. Another way of looking at this is 1 hour work for each of them is 1/4 plus 1/8 minus 1 over 12. And I will multiply this by the total time the pipes are open, and they will complete one job. Okay? So here we have a rational equation actually, but it is what? Linear. Okay, so what do we do here now? How do we solve for this? I can solve this. Combine these fractions. So I will have now my solution. So I will combine this fraction. LCD will be what? 24. Okay? 24 divided by 4 is 6 times 1 is 6. 24 divided by 8 is 3 times 1 is 3. And 24 by 12 is 2 times 1 is 2. Is equal to 1. So 6 plus 3 is 9. Minus 2 is 7. So I will have here 7 over 24 equals 1. If you look at this, my answer here now will be, I have here 7 over t. Okay, this is 7 over t over 24 equals 1, or 7 over t equals 24, or t is what? 24 or 7 over 7 hours. Okay, so this is 24 divided by 7. That will be equivalent to 3 and 3/7 hours. Okay? So, that's how you do a work problem. You will always have to deal with this equation. Work equals rate times time. Okay? So, that's the second problem. Example number 3, we have... Okay, for this example, let's read through. Each member of a class should pay equal share on a 1,000 peso expense for a trip. When 5 other students from another class joined, the share of each was reduced by 10 pesos. And the question here is how many students joined the trip. So, what is our representation? Originally, let's say, let n be the original number of students who joined. Okay? Who joined here. Okay. Now, since 5 students have been added, we get here, and plus 5 will be the total number of students who joined. Okay, if we look at the problem, if 5 students would go to the trip, then this 1,000 will be divided among them equally. 5. Okay? So, here, in this case here, if there will be n students dividing this 1,000, this will be 1,000 over n. However, if there will be 5 more students who will join, then this 1,000 over n share will become smaller. So, the share of each one now will be 1,000 over n plus 5. So, we will be working on these rational expressions here to have our equation. Okay? So, our equation now will be, there is a difference of 10 pesos from this original here and this new fraction here, the price when there are only n students minus the price when there will be n plus 5 students, the difference is 10. So this is now going to be the rational equation that we will be solving. Okay? How do we solve that? That's our solution. I can multiply everything by the LCM. LCM of all the denominators. So, I will get here n times n plus 5 times 1,000 over n minus 1,000 over n plus 5, okay, equals 10. Okay, that's how it goes. And how will the solution be? This 1 times this, n cancels out. So I will get 1,000 times n plus 5 on the first term. This one and this cancels off. I will get 1,000 n. And then this 1 times this, I will get 10n times n plus 5. Okay? Simplifying this, we get 1,000n plus 5,000 minus 1,000n equals 10n squared plus 50n. Okay? Okay. Simplifying this, we get this one cancels off, this one cancels off. So I have 5,000 on one side. I can transfer it to the other side. And my equation now becomes 10 squared plus 50n minus 5,000 equals 0. Now, I can multiply this by 1 over 10. And this gives me n squared plus 5n minus 500 equals 0. Okay? So, this one is factorable. I can have my factor n and n plus 25 minus 20. So, 25 times 20 is 500. The middle term is 5n. Now, from the zero product property, I can get n equals negative 5 or n equals 20. Only this value of n can be considered, okay? Because we don't have a number of people which is negative. Therefore, our answer now is asking us how many students joined the trip. The total number of students who joined the trip is n plus 5, or this is 20 plus 5 equals 25 students. Okay? That's example number 3. Okay. Let's have the next problem. The next problem is a distance problem actually. From your previous work in math, distance here is equal to rate times time. Okay? Rate times time. Okay, so what is my representation here now? We are being asked what's the speed of the current. So let's say, let C be the speed of the current. Okay, what are we interested of here? I always make it a point to make a table of the information if I have this type of problem. So, the boat goes upstream. So, suppose this is the stream, okay? The speed of the boat in still waters, the speed of the boat in still water will be impeded by a current going down. This is C, and then this is the boat. If the boat is going up, the speed of the boat will be, let's say, B minus C. But if the boat is going down, the speed of the boat will be B plus C. Okay, the current will help the boat go down, but the current will impede the boat going up. Okay, so let's see. We will divide this table into the action going upstream and then downstream. Still water means you are not going up or down stream. So the distance here, the boat goes 24 kilometers upstream. So if that is 24 kilometers upstream, that should be the same 24 kilometers going downstream. So it has traveled the same distance. Okay, the thing here is, our equation here talks about the total time, which is 4.5 hours. Okay, so if this is my rate and this is my time, my rate here, the speed of the boat in still water is 12 kilometers per hour. So if it goes up there, it will not be 12 kilometers anymore. But that will be impeded by a current, which is C kilometers per hour, the speed of the current. And when the boat goes down, this will be aiding, current will aid the boat speed. Okay, now, if we express the time here, if we have d equals RT, time will be actually distance over rate. So this distance here is 24 divided by the rate, which is 12 minus C, is the time the boat takes to travel 24 kilometers upstream. And the time it goes downstream for the same distance will be 24 over 12 plus c. Therefore, this one will give us our equation. Equation now will be time going up, time up plus time going down equals how many? 4 and 1/2 hours, or this is 9/2. So time going up is 24 over 12 minus c plus time going down 24 over 12 plus c equals 9/2. So this is our rational equation. How do we solve this rational equation? We are going to multiply this by the LCM of the denominators again. So this will be 12 plus c. Okay. Distributing this, I will cancel 12 minus c. I'll be left with 2 and 12 plus c. So 2 times 24 is 48 times 12 plus c. The other one, this 12 plus c cancels off. I will get here 48 times 12 minus c equals, if I multiply this and this term, 2 and 2 cancel out. I will get here 9 times 12 minus c and 12 plus c. Okay, multiplying the two, we get what? 48 times 12 is 576 plus 48c. And this is 576 minus 48c. This 12 minus c times 12 plus c is actually a difference of 2 squares. 144 minus c squared. So I'll multiply this by 9. So I will get 1296 minus 9c squared. Simplifying this, what do we get? I have 48c cancels off with this, and 576 plus 576 will be 1152 equals 1296 minus 9c squared. Okay? So that this will be now my solution here. Okay? Now, I can solve for c. This is a pure quadratic. I can transfer c, 9c on the other side, and I will get here 1296 minus 1152. And I will get here c squared over 9. And then 1296 minus 1152 is what? 144. And extracting roots, I get c equals plus or minus square root of 144 over 9, or this is plus or minus 12 over 3, or this is plus or minus 4. But our answer should only be the positive value of c. So c should be equal to 4. So the speed of the current is 4 kilometers per hour. Okay? So remember, when you deal with distance problems, this is a must, the equation, d equals RT. And it will always be helpful if you will make use of this table. Okay? See you in the next video.